Right, today we're doing AMC 12A 2024, problem number 8. How many angles theta that lie between 0 and 2 pi satisfy the following expression? Okay, so we can simplify this expression a bit by the property of logs to be log of sine of 3 theta times cosine of 2 theta equals 0. Because these logs all share a common base, we could do this. And we know by definition of logs, AB equals C, B equals log AC. So here, this would be sine of 3 theta times cosine of 2 theta equals 10 to the power of 0, which is 1. So we know sine of 3 theta times cosine of 2 theta has to be equal to 1. So when is this true? When does the theta satisfy this expression? Okay, if we draw out the graph of sine and graph of cosine, we know sine looks something like this and cosine looks something like that. If sine of 3 theta is, we know this has to be between -1 and 1, and cosine of 2 theta has to also be between -1 and 1. But anytime it's negative, right? Anytime cosine of 2 theta gives out a negative value, or anytime sine of 3 theta gives a negative value, we have like log of some negative number. And logs cannot have a negative number in its argument. So we know in our practical purpose, we should only analyze when sine of 3 theta spits out a number between 0 and 1, and cosine of 2 theta spits out a number between 0 and 1. Okay, so when is this true? In our graph of sine and cosine, we can ignore the negative parts. So these parts are here. If cosine spits out a number between 0 and 1, so like it spits out a number like 0.6, like 0.3, what must sine be in order to make this 1? Well, that would be 1 over a number like 0.6. So sine has to be a number that's greater than 1. So anytime cosine spits out a number that is less than 1, right? Sine has to spit out a number that's greater than 1 in order to counteract that and make the result a 1. So, but sine can never go above 1, right? Because we did not multiply anything in front of sine. So we, sine can only give out a number between 0 and 1 here. So we see that the only time it will be 1 is when sine of 3 theta spits out 1 and cosine of 2 theta spits out 1. This is the only case that this could happen in. So, when does this happen? We know sine of 3 theta. When sine of 3 theta is the same as, okay, let's think about it like the sine of pi over 2 gives out 1, right? Sine of pi over 2 gives out 1. And then sine of, is there any other number that gives out 1? Well, it has to be added with 2 pi. So 2 pi plus pi over 2, which will be sine of 5 pi over 2. This gets 1. So 1 is 3 theta equal pi over 2. 1 is 3 theta equal 5 pi over 2. 1 is 3 theta equal 5 pi over 2 plus 2 pi, which is going to be 9 pi over 2. Theta will be pi over 6. Theta will be 5 pi over 6. Theta will be 9 pi over 6. Okay, so this is the thetas. When you plug into sine of 3 theta, that will give out a 1. Now, does cosine have the exact same thetas for this to happen? Because, they're the same argument, they're the same theta. Well, when is cosine equal to 1? We know cosine of 0 equal 1. And cosine of 2 pi equal 1, and cosine of 4 pi equals 1, all the way dot dot dot. So that means 3 theta has to be equal to this 0 right here. 2 theta has to be equal to that 0 right there. 2 theta has to be equal to 2 pi. 2 theta has to be equal to 4 pi. And then, 2 theta has to be equal to 6 pi. Okay, so this means theta has to be equal to 0. Theta has to be equal to pi. Theta has to be equal to 2 pi. And then we could ignore this last argument. So we see that none of these thetas match. None of these thetas are the same. So this probably means that our answer is 0. None of the angles of theta between 0 and 2 pi would satisfy this expression right here. And that will be our answer.